Now, moving ahead in the chapter, and finally we reached the last topic of chapter Simple Machine, which is inclined plane. So, now we can see that here is a plane. Let this plane is AB, which is inclined at some angle, which is theta. Now consider a pulley is situated at this particular point on this inclined plane. The weight of the pulley capital W will be acting downward. Weight हमारा हमेशा डाउनवर्ड एक्ट करेगा. नाउ दिस एंगल इज थीटा, सो ये वाला एंगल हमारा 90 होगा. सो सिंस द सम ऑफ ऑल द इंटरनल एंगल्स ऑफ अ ट्राइंगल इज 180, सो दिस एंगल, ये वाला एंगल आपका 90 माइनस थीटा होगा. नाउ ये एंगल 90 माइनस थीटा है, तो ये वाला वर्टिकली ऑपोजिट एंगल, सो दिस एंगल विल ऑल्सो बी इक्वल टू 90 माइनस थीटा. ऑन सॉल्विंग वी विल गेट दिस एंगल, दिस स्मॉल एंगल between W and W cos theta is theta, so this angle can be written as theta. Now since this part is W, so W can be broken into two components, as I have told you in the chapter where I have discussed about the work, and the formula of work was F into D into cos theta. On the similar basis, W can be resolved into two parts. First part is W cos theta and second part is W sin theta. Now आप देख सकते हैं ये जो हमारा पुली है, ये W sin theta फोर्स की वजह से नीचे की तरफ जाएगा. सो अगर हम पुली को ऊपर ही रोकना चाहते हैं तो हम क्या करेंगे, एक एफर्ट लगाएंगे, और वो एफर्ट किसके इक्वल होगा, द एफर्ट शुड बी इक्वल टू W sin theta. तो इसका मतलब ये हुआ कि W sin थीटा फोर्स लगा के हमने W वेट की पुली को नीचे जाने से रोक लिया है, विच मीन्स योर लोड इज इक्वल्स टू कैपिटल W एंड योर एफर्ट इज इक्वल्स टू W sin theta. So I hope you appreciate this point, that your load is equals to W, that is the weight of this pulley is balanced by applying an effort of W sin theta. So the effort is W sin theta and your load is W. Now we will look to calculate mechanical advantage. We know MA is given by load upon effort. So load is equal to W and effort is W sin theta. So simply W will get cancelled and you will get 1 upon sin theta. Now sin theta can be easily calculated from this figure if we apply sin theta, since sin theta is equals to perpendicular upon hypotenuse. So your perpendicular, since this angle is theta, so perpendicular will be equal to H and hypotenuse will be equal to S. So sin theta is equals to H upon S. Your hypotenuse, this whole distance is considered as small s. So your sin theta will be equal to H upon S. Now replacing the value of sin theta, we get MA is equals to 1 upon H upon S. So S will go to the numerator. So your expression becomes S upon H. That is your mechanical advantage is equals to S upon H. Now we can easily see that since ABC is a right angle triangle, so S is the hypotenuse of this right angle triangle and H is the perpendicular. So we all know that hypotenuse is always greater than the perpendicular. So which means S is greater than the H. Now let S is equals to 100 centimeter and H is equals to 10 centimeter. So MA is equals to 100 upon 10, that is 10. So we can easily see that MA is greater than 1, which means this inclined plane can be used as a force multiplier. Now let us talk about velocity ratio. Since velocity ratio is given by displacement in the effort arm divided by displacement in the load arm. So from the figure we can see that the maximum displacement in the effort arm can be equal to S, because if let pulley is at this particular point, so pulley can be drawn up to this point, which means the maximum displacement in the pulley is equal to S. Now talk about load. Since pulley is kept at this point, so it can go up to only this line. So the maximum displacement in the load, since pulley is the load, is equal to the H. So velocity ratio is also equal to S upon H. So velocity ratio is also going to be greater than 1. Now since efficiency is equal to MA upon VR, since both are same, so then efficiency will be equal to 1, that is 100%. Theoretically efficiency is 100%, but practically efficiency is bit less than 100%, because there is always a friction present between this pulley and this surface. So this friction reduces the efficiency up to some extent. So I hope you will be able to understand this chapter about this topic about inclined plane. Thank you. If you find it difficult to understand, you can ask me. Okay, thank you very much.